Hello 20-1 students. So today we're looking at adding and subtracting rational expressions. So just kind of moving forward from where we were last time, where we were looking at multiplying and dividing and kind of doing those operations in combination as well. So just a little bit of a review of what you should kind of know about adding and subtracting fractions in general. So starting out with working with just numerical fractions, and then we'll kind of extend these ideas into rational expressions as we move through the lesson today. So if we're looking at this operation here, we have 3/5 plus 8/5 minus 6/5. So keep in mind when you are working with fractions, you need to, if you're doing adding and subtracting, you need to have a common denominator. So in this one, they all have the denominator of 5. So once you have a common denominator, you can do the operation straight across the top. So basically, like, we would have 3 plus 8 and then minus 6. Whoops, I guess I have to put the minus sign in there. Minus 6. Okay, and so basically what we can do is just say that that's like all over 5, because it doesn't matter if you write it together or separate. So 3 plus 8 is 11, minus 6 is 5, and then we still have it over the denominator of 5. And then of course if we simplify that down, 5 divided by 5 is 1. So simplified from these fractions, we find that we have a final answer of 1. In the next case here, we have 3 different fractions, kind of similar operations, subtracting and adding, but we have different different denominators. And so what we need to do is make sure that they all have the same denominator. So remember, you always want to look for the lowest common denominator, which is the lowest number that all of these numbers can multiply into. So the lowest value that 4, 3, and 6 can all be multiplied into would be 12. So what you want to do is work with each fraction to make it so that the denominator is 12. So in this case, if we have 3 over 4, what would we need to do that in to make it into 12? To make 4 into 12, you need to multiply it by 3. Now remember, in order to change a fraction, you always want it to be an equivalent fraction. So essentially that means the number value is the same. The way we represent it is the only thing that's changing. And so that means if you multiply the bottom by a number, you need to multiply the top by the same number so that we're not changing the difference between those values. So 3 over 4 times by 3 over 3, remember, just multiply straight across. 3 times 3 is 9, 4 times 3 is 12. If you're ever uncertain if you have equivalent fractions, remember you can just do the actual math. So if you do 3 divided by 4 in your calculator, you should get 0.75, and you should get 0.75 if you do 9 divided by 12. Okay, so the next one we have is 2/3. How can we make 3 into 12? We need to multiply it by 4. So then that means we need to multiply the top by 4 as well. 2 times 4 is 8, and 3 times 4 is 12. And then the last one is 1/6. And how do we make 6 into 12? We need to multiply it by 2. So we need to do that to the top as well. 1 times 2 is 2. 6 times 2 is 12. So now that we have these all set up with the common denominator, we can go ahead and do our operations. So 3 over 4 was 9 over 12, and plus 2 over 3, which is 8 over 12, minus 1 over 6, which is 2 over 12. 9 plus 8 is 17, minus 2 is 15 over 12. Okay, so the denominator doesn't change. Now we would just want to simplify to lowest terms. So what value can be divided into 15 and 12? 3 goes into 15 5 times, and into 12 4 times. So that'd be 5 over 4. Neither of those numbers can be reduced anymore, so we know we used our best way for making that simplified. And so that's our final answer there. So we're going to be using these same concepts a lot with our not a lot. We are going to be using these same concepts exactly for working with rational expressions. So essentially that means that if you don't have a common denominator, which is what we'll mostly be looking at, you need to make it into a common denominator. If you already have a common denominator, you just have to do the operation for the numerators as it's listed. Okay, so the steps are outlined here, but I'm just going to go ahead and work through. You can always use these to refer back to if you need to. So for example 1, first thing always just looking at the denominator, we do have a common denominator there, so that makes things nice and easy because then we can just do the operation for the top 2 for the numerators. I'm just going to get rid of this in case I need the space. So basically that means we have 10m minus 1 is 1 minus 8 minus 2m. And I'm just going to automatically set this up so that it's all kind of one fraction because it's all over 4m minus 3. Okay, now I just need to, on the top, combine like terms. The trickiest part with this is usually making sure that you keep in mind that there's this subtraction between the 2 expressions. So you need to keep that in mind as well as the value, the positive or negative value that's in front of each of the terms in the second bracket. So basically here we have, if we look for our like terms, we have 10m and 2m, right? And then the other values are just number values, so those will be our other set of like terms. So 10m minus, and then keep in mind that other value here, 10m minus negative 2m ends up being 10m plus 2m, right? So 10m plus 2m is 12m. And then for our number values, we have negative 1, so remembering to keep the negative with the value that follows it, negative 1 minus, and then this one has no value in front of it, so it's just plus 8. So negative 1 minus 8 gives us negative 9. So now our simplified expression on the top there is 12m minus 9 over 4m minus 3. Now what we want to do is look to either one of these and see if we can simplify them further. So basically if we can factor them. So on the bottom here, 4m minus 3, there's no common term there that we could factor out. But on the top we have 12 and 9. Both of those you can factor a value of 3 out. So if we take 3 out front, 12 divided by 3 would be 4. And then the m has to stay with it, of course. And then 9 divided by 3 would be 3. So 4m minus 3 there. And then on the bottom, 4m minus 3. Now looking at the new expression we have, can we simplify this at all? Well, 4m minus 3 divided by 4m minus 3, remember those like terms are going to cancel out. So we're left with, as our final answer, just 3. The last thing we need to do is look at non-permissible values. Okay, so although here actually I did write it first. Sometimes you can do this first. Honestly, for these ones, actually, maybe I should even change that in the notes. I prefer to look at the end because that way you can remember to look at all of the different steps. Now for this one, because we only had one denominator, it's fairly straightforward. So we would say non-permissible values are, this is the only expression that we have. So remember, basically, in order to solve for the non-permissible value, you would say 4m minus 3 cannot equal 0, which means 4m cannot equal 3, and that means m cannot equal 3 over 4, right? You would have to divide that out. So our non-permissible value is m cannot equal 3/4. Ooh, that's getting close to the bottom of the screen there. And that's the only one because we only had that one denominator. Okay, let's try one more. That's weird. Hold on a second. Oh, because that was from the previous lesson. I was wondering. I didn't think that was my next example. Okay, so with this one we have three operations to look at, but again we have x minus 3x plus 1, x minus 3x plus 1, x minus 3x plus 1. So common denominator, so we can just look at working with our operations for the numerator. So we're going to have 2x squared minus x plus, and then in brackets, 3 minus 6x, and then minus 8. I'm not going to put a bracket around that because it's just a single number instead of an expression. And then on the bottom, x minus 3, x plus 1. Okay, so now, let's see, we just want to combine like terms again. So I'm just going to grab one more highlighter here. We have 1x squared term, no other ones. So that one's going to stay the same. So when we rewrite this out, we're going to put in 2x squared. Then in terms of just x terms, we have negative x, so that's kind of the same as like negative 1, minus 6x. Those are our only two x terms. So negative 1 plus negative 6 is the same as negative 1 minus 6. So minus 7x. And then for numerical terms, we have plus 3, so positive 3, minus 8. So plus 3 minus 8 gives us minus 5. And then on the bottom, we still have the same set of terms there. So it's going to be x minus 3, x plus 1. Okay. So now we would just want to see if we can factor anything out of this. So what I would do is look at the swing method. So remembering that's going to be, we get the 2 out of here and use it to multiply the last term. So we're going to have x squared minus 7x minus 10. Right, so using the 2 to multiply by the last term, and then see if we can figure out anything that would factor there. So two numbers that multiply to negative 10 and add to negative 7, like 10 and 1 or 5 and 2 are our only options. 5 and 2 don't actually work because in order to get to negative 10 you would need 1 positive and 1 negative, but we need it to add to negative 7, in which case you would need negative 5 and negative 2. So basically this isn't going to work in terms of factoring, so that means this is our most simplified version, so we can kind of leave that as is. And then the only other thing we want to do is solve for our non-permissible values. And this one's nice and easy because when you have two sets of brackets like that, remember it's just the opposite sign of each of the numbers. So we're going to say x cannot equal positive 3 or negative 1. Those are our NPVs. Okay, so hopefully pretty straightforward, especially with the common denominators. Now you guys can try a couple of your own here. The answers are at the bottom of the page. So if you want, you can pause the video and give those a try. And then we'll move on to the next section here. All right, so the next thing we want to be able to do is work with expressions that do not have a common denominator. So in this one we have 2x minus 1 over 6 plus 3x plus 2 over 4. So just number values on the bottom makes it a little easier to figure out the common denominator. The lowest number that both 4 and 6 go into evenly would be 12. So we would say LCD equals 12. To make 6 into 12 we need to multiply it by 2. So 2x minus 1 over 6 times by, remember if we need to multiply the bottom by 2 to make it into 12, we need to do the same thing to the top. So that gives us 2 times by 2x is 4x, 2 times by negative 1 is negative 2, and then 2 times by 6 is 12. Okay, then the next one for 4, we're going to have 3x plus 2 over 4. And to make 4 into 12, we need to multiply it by 3. So we're going to go times by 3 over 3. So again, just multiplying through both terms. 3 times 3x is 9x. 3 times by positive 2 is positive 6. So 9x plus 6 over 12. Now, all we needed to do was add these two terms together, so I'm just going to kind of bump this one up here so I can do that. So 9x plus 6 over 12, and I'm adding them. So again, looking for like terms. Boy, I keep misplacing my highlighters. There they are. Okay, so 9x, so 4x. I want to combine with 9x. They're both positive and we're adding them, so that's going to give me 13x. And then negative 2 plus positive 6. So negative 2 plus 6 is plus 4. And all of that will be over 12. So that's our final answer for this one. We can't factor anything out of 13x and 4, right? There's no common factor there. So we can leave that as our final answer. The other thing is with two numerical denominators, you're not looking for a non-permissible value, right? That only applies to variables. So we don't have to worry about the NPV for this one. All right, in the next one here, so we have expressions as the denominators, and yeah, I mean the numerators are a little bit more simplified in this one, but first of all what we want to do is see if we can factor either or both of these expressions. So the first one, we have 3 over 3x plus 9. Obviously we can't factor anything out of the 3, but 3x plus 9 has a common factor of 3, so let's pull that out, which means we would need to multiply it by x plus 9 divided by 3 is 3. So there's our factored version of the first expression. For the second one, we have 16x over 4x minus 12. So again, can we factor anything out? Well, on the bottom, we can factor a 4 out of both of these terms. So then we would have x minus 4 times 3 will give us 12, so x minus 3. On the top, in terms of factoring, once we have the bottom factored, we basically just want to see if we can break this down into any terms that would help us to simplify the bottom. So 16 is 4 times by 4x. Would give us 16x. So now we've pulled out a factor that we had on the bottom so that we can cancel. So this is our next step for both of these expressions. Now that we've factored them, we want to see if we can simplify them by canceling out like terms between the numerator and the denominator. So we have 3 and 3 here, and we have 4 and 4 there. So we're left with, remember, if you cancel out the top term, it's just going to be 1 over the denominator, so x plus 3. And on the bottom, we're going to have 4x over x minus 3. Okay, so now that these two expressions are as simple as they can be, we want to give them common denominators. When you have two different terms, basically the only way to do that is to multiply each by the term that's found in the opposite expression. So like this one has x plus 3 on the bottom, so in order to give this one a common denominator, it's going to have to be x minus 3 times by x plus 3, and for this one we're going to have to multiply the x plus 3 times by x minus 3. Which means we're going to have to multiply the numerators by those same things. So we're going to multiply this by the denominator of the other fraction, or expression rather, I guess. So we're going to do x minus 3 over x minus 3. And then for this one, we're going to multiply it by x plus 3 over x plus 3. Okay. So 1 times by x minus 3 is just going to be x minus 3. And then on the bottom, we're going to have x plus 3 times by x minus 3. Then on this one, we're going to have 4x times by x plus 3. So make sure you multiply by both terms. 4x times x is going to give us 4x squared. And then 4x times by 3 is going to give us plus 12x. and then on the bottom we're going to have the x plus 3, x minus 3. Okay, so now that we have common denominators, we want to do the operation with the numerators. So we're going to have x minus 3 is one expression. Our operation is to subtract, and then 4x squared plus 12x. And all of that will be over the common denominator we just found, which was x plus 3 times by x minus 3. So now we want to combine like terms. So our only like terms here actually are the x values. So we're going to have x minus 12x, which is going to give us negative 11x. I'm actually going to write this a little bit differently. So I want to end up with this with like kind of like a quadratic function here. So I'm going to start off with the 4x squared. I'm going to put that negative 11x in the middle. So here we have an expression minus 4x squared. So that just basically means we're going to put it as negative 4x squared. Negative 4x squared minus 11x, which we already calculated. And then for our numerical value, we just have minus 3 here. And all of that will be over x plus 3, x minus 3. And so we have our final expression. Now, if you wanted to, you could try and factor this one. I'm not going to walk through it because that's not the point of this lesson, but you actually won't be able to factor that into any kind of lower terms like into brackets. That would cancel out. So we can leave this as our final answer there. And let's see, then we just have to solve for our non-permissible values. So just remembering that that means you need to look at all of the denominators throughout. And so this was our first one where we had our value for x would not be able to be equal to negative 3 here and positive 3 here. And then of course, because that becomes our common denominator, that's true for the whole operation. So basically our non-permissible values are, x cannot equal negative 3 or positive 3. So we can just write plus minus 3 there. Okay, so you have a couple to try for yourself that have different denominators, and the answers are at the bottom. And then we'll do one more example before we wrap up for today. A little bit more complex, or sorry, two more examples, I guess. So with this one, this one, we're starting out with pretty complex expressions on the bottom here. Top is fairly simple. So like we have mentioned before, we want to first of all factor. So obviously the top or the numerators for both of these you can't factor. They're already as simple as they're going to get. But these bottom two we can. So I'm going to use the swing method here. So I'm going to multiply 2 by the last value. So I'm going to have x squared plus 7x minus 15 times 2, so minus 30. That means I need two numbers that multiply to 30 and multiply to negative 30 and add to 7. So that would be positive 10 and negative 3. X plus 10, x minus 3. And then I'm going to have to divide out that 2 that I carried through. So for this one, that simplifies properly. So it's going to be x plus 5. For this one, we end up with a fraction, so I have to swing the 2 over, 2x minus 3. So there's my factored version for that denominator, and I also want to factor this one. So same set of steps. I'm going to move the 2 over, so I'm going to have x squared minus 11x plus 12 times 2 is 24. Two numbers that multiply to 24, positive 24, and add to negative 11 would be negative 8 and negative 3 are going to add to negative 11. So x minus 8 and x minus 3. And then, of course, I need to divide out the 2 again. So we're going to have x minus 4 And again, this one leaves us with a fraction, so we have to do 2x minus 3 there. Okay, then solving for our lowest common denominator. So these are both of our denominators here and here. Both of them have 2x minus 3, so I don't need to, so I only need to have one of those in my common denominator, and then I'm going to have an x plus 5 and an x minus 4. So basically these are going to be the three terms that I need to have in my lowest common denominator. So we can say LCD is going to be equal to x plus 5, 2x minus 3, and then from this side, x minus 4. So what does that mean? Well, if this expression has both of these in its denominator, and we need it to include x minus 4, that means we need to multiply the top by x minus 4. So we're going to have x times by x minus 4 all over the 2x, or x plus 5, 2x minus 3, and x minus 4. Okay, and then on the other side we're going to have plus x plus 1. Now this one had 2x minus 3 and x minus 4. So in order to include the x plus 5, we just need to multiply that through. So we're going to have x plus 1 times by x plus 5. Because our common denominator had to have the x plus 5 multiplied to have the full thing. So x plus 5, 2x minus 3, x minus 4. Okay, so now we just want to multiply out these two expressions so that we can simplify them because we'll have like terms. So here we're going to have x times x is x squared. X times by negative 4 is negative 4x. Plus, and then on this side we're going to have x times x is x squared. X times by 5 is 5x, plus 1x is 6x. So I'm just going to combine those in one step. And then plus 1 times by plus 5 is plus 5. So x squared plus 6x plus 5. And all of that, I'm just going to put these over the same denominator here. So x plus 5, 2x minus 3, 2x minus 3, x minus 4. And then now I can just combine my like terms. So I have x squared plus x squared gives me 2x squared. Negative 4x plus 6x gives me plus 2x. And then I just have the plus 5 at the end there. And all of that is going to be over x plus 5, 2x minus 3, x minus 4. Now again, for our final answer, if you can factor this, you will, but I've gone through and tried it and you can't simplify that anymore. So obviously if you're doing this on your own, make sure that you do try. Now the last thing we want is our NPVs. And so we will have x cannot be equal to, going through all of our factored ones, x plus 5, so x cannot equal negative 5. Here we're going to have positive 3 over 2. And then on the other one, positive 4. And again, we have the positive 3 over 2, and that's applicable for the rest of our operations. So those are all of our non-permissible values. Okay. Let's try one that's a little bit more complicated. This is going to combine basically everything that we've learned so far. So it's going to include adding and subtracting as well as multiplication and division. So in this one, first of all, we want to look at what we've got here, right? We've got two fractions being added, two fractions being subtracted, and they are being divided by each other. So just the way if you had like 3 plus 6 over, I don't know, 2 plus 4 as a fraction, you wouldn't try try to divide this before you combine the terms, right? So we would, go 6 plus 3 is 9, plus over 2 plus 4 is 6. That's how we would work, right? And then if we wanted to get like a decimal value, then we would divide the values. Same thing is true for a rational expression. So first we want to combine our terms in the numerator and the denominator. Then we can look at doing our division. So first of all, we want to do 3 over 2 plus 3 over t. So in order to do that, we need to look at our lowest common denominator, which would be, we need the factors from both denominator, basically. So lowest common denominator, lowest common denominator is going to be 2t. Okay, so essentially that means we're going to have to do 3 over 2 times by t over t. I don't know why I did that first, but whatever. 3 over 2 is going to be equal to 3t over 2t. And then 3t, in order to make that into 2t, or sorry, 3 over t, in order to make it into 3 over 2t, we have to multiply it by 2 over 2 times by 3 over t. So that's going to give us 2 times 3 is 6 over 2t. And so now we can combine them, right? So I'm just going to bump that up. They're being added together. So 3t over 2t plus 6 over 2t. 3t plus 6 is just going to be 3t plus 6 over 2t. And then if we can factor to simplify it all, we want to do that. So obviously we can't do it for the denominator, but on the top we can factor out 3. So we'd have 3 bracket t plus 2, right, to make it into t plus 6, and then divide that by 2t. Okay, so there's our top term. On the bottom we have t plus 6 and then t. So our lowest common denominator for that one is going to be t times by t plus 6. Okay, so remember that you have to include all, like if the factor appears once in denominator, it has to be represented in the common denominator as well. Okay, so now let's see, if I want to make t plus 6, I want to multiply that whole thing by t over t, times by t over t plus 6. T times t is t squared, and that's divided by t times by t plus 6. Okay. The next one we have is 1 over t. So to make that into t times by t plus 6, we have to multiply both by t plus 6. Times by, let's see, 1 over t. So 1 times by t is going to be t. 1 times by 6 is 6. So I guess we know that 1 times by anything would just still be that thing. So t plus 6. Okay, and so now we want to, in this case, subtract those. So I'm just going to bump this guy up here so we can do the operation. So minus t plus 6 over t times by t plus 6. And that's going to give me t squared. There's no like terms on the top, so it's just going to be t squared minus t minus 6. T squared minus t squared minus positive 6 is still minus 6. And all of that will be over t plus 6. Okay, so now we have the numerator and the denominator, and then we want to think about what's happening here, which is that we're going to have this, so 3 times by t plus 2 over 2t is divided by t squared minus t minus 6 over t times by t plus 6. Remember that the easiest way to do this is, of course, to multiply by the reciprocal instead of trying to find a common denominator for these two again. So that means we're going to do 3t plus 2 over 2t multiplied by, and flipping this around. So on the top, we're going to have t times by t plus 6. And on the bottom, we're going to have this, which we should actually simplify before we move on. Let's simplify that into brackets for multiplying. So two numbers that multiply to -6 and add to -1 would be -3 and +2, t plus 2. Okay, so we can simplify into those brackets there. So t minus 3, t plus 2. I maybe should have done that earlier up there, but I forgot to do it. Okay, so now we have this simplified and we can go ahead and multiply straight through. So, oh, actually we have a common factor we can take out here. That's going to make things a lot easier. That's our only one that we can cancel out. Oh no, we have 2 times t, and we have t times that up there, so we can factor that out as well. I think that's everything there. Okay, so now we can do, it's going to be 3 times by t plus 6 divided by 2 times by t minus 3. And out of this, we can't factor anything out. 3t plus 6. Yeah, no, you can't factor that any simpler. So that's going to be our final answer for this one. Then we just need to state our NPVs. So it's going to be t cannot be equal to, remember to look all the way through. So we had 2 times by t up here. So remember, whenever you have t being multiplied by anything, it can't be 0. We also had t being multiplied here. So that's another instance where t can't equal 0. What else do we have? T plus 6. So it can't be -6. And then when we flipped to multiply, when we use the reciprocal, we have this as a denominator, so we need to include that as well. So it would be +3 and t plus 2, so -2. So those are all of our NPVs, remembering that you have to look at the values for all of the denominators that you use throughout the process for that. Okay, so that's kind of about the most complex type of a question that you'll get for this in terms of combining all of the operations that we've looked at. So hopefully that helps you out. There's a couple of questions for you to try yourself, and the answers are given down here. And then you also have an assignment from the textbook to work on. I've also mentioned some of the standard of excellence questions here. So if you can do 15 and 18, those are basically like the most challenging kind of questions that you would find for this material. All right, so that is everything. And next time we'll be looking at solving rational equations. So just kind of getting into more, like putting all of this material together into more complex types of questions. So I will see you in that lesson.